So today we will be studying about periodic table. In this we will start with periodicity in certain properties like electron affinity. In the previous lecture we have covered some of the properties like atomic radius, atomic volume, density, melting point, and ionization energy. So today we will be dealing with electron affinity. So what is this electron affinity? It is nothing but the energy released when an electron is added to an isolated atom. It can be defined in other way also, as it's a tendency of an atom to attract the electron, tendency of an isolated atom to attract the electron towards itself, because tendency to attract the shared pair of electrons is electronegativity. Here the energy released when an electron is added to an isolated gaseous atom is called as electron affinity. Electron affinity, a thing which has to be kept in mind is electron affinity is a property, it's a chemical property. There is another term which we use for this, is electron gain enthalpy. Electron gain enthalpy is defined in terms of energy. So more the energy, more the electron gain enthalpy, more is the amount of energy released, and more is the electron affinity. Less is the electron gain enthalpy, less the amount of energy released. So its units are electron volt per atom, kilojoule per mole, is energy released for 1 mole, is the energy released for 1 atom. So likewise in ionization energy we discussed it is IE1, IE2, IE3. In this also there is one EA1, EA1, EA2, EA3. Now what is that? When an electron is added to an atom, isolated atom, it turns to an anion and some energy is released. The energy released in this step we will call it as EA1. Okay, and after this, when an electron is added to this negative charge anion, which is obviously difficult because the negative will apply the force of repulsion. Now this will convert to -2. So the energy which will be required in this process will be called EA2. The thing which we have to notice here is EA1 is the energy released, while EA2 is the energy required. Why it is so? It is why it is called the energy required, because in first step the energy released, while in second step the energy is required for the addition of the electron to the negative ion. As the reason I told you, because the addition of electron to a negative ion is difficult. Thus we have to supply energy instead of releasing. Now there are some factors which are affecting the electron affinity. Those are, first is a nuclear charge. Now what is this nuclear charge? The charge on the nucleus for the atomic number of protons. The relationship which we'll define in this is electron affinity is directly proportional to nuclear charge. Now what does this mean? This means on increasing of nuclear charge, the electron affinity increase. Thus when we will discuss this trend in a period, the electron affinity will increase on going from left to right. The reason being, on going from left to right, the atomic number increase, thus the nuclear charge increase, thus which leads to increase in electron affinity. Logically, if we think, if the coming electron which you are adding will be attracted more when the atomic number is more or the nuclear charge is more. So that is obvious. Now the second point which we will deal with is atomic size. Now what does this atomic size signify? This signifies that more is the atomic size of an atom, the addition of electron, the electron affinity will be less if the size of the atom is more. So in terms of relationship wise, we can say that atomic size is inversely proportional to electron affinity. Third factor is the electronic configuration. The elements which are having a stable electronic configuration have very less electron affinity. This is because they don't want, the stable atoms will not want to disturb their stability by accepting some more electrons. When we will see the trend of electron affinity in a group, it will be like this. On going down the group, the electron affinity will decrease. See, because we can say that the atomic size is increasing, but nuclear charge is also increasing. But here this increment in atomic size surpasses increment in nuclear charge. So what will happen when the atomic size will increase over a atomic size will surpass nuclear charge, then overall, and we know that atomic size is inversely proportional to electron affinity, overall the electron affinity will decrease on going down the group. Now there are some irregularities observed in case of electron affinity. Now what are they? We said that the electron affinity continuously decreases on going down the group in a periodic table. But this does not happen always. For example, the electron affinity of the third group is greater than the electron affinity of second group. The reason being, second group is having compact size. For example, we will understand this with the help of an atom. This we have drawn an atom. The coming electron which we are adding, if this is small, okay, now we consider the big atom. If it is congested, too many electrons are there, size is small, the nucleus which is in the center will attract this incoming electron with a less force. This we call it as second group. If the third group we consider, then what it will be? In the third group, the nucleus is in the center, okay? The coming electron will be attracted more by more power because there are less repulsions observed when the electron will be added, because the atom is slightly open up and the electron will be having less force of will be attracted, the incoming electron will be attracted by more power. Thus what will happen? The electron affinity of third group will be greater than electron affinity of the second group. Also, as I have discussed, there is a role of electronic configuration in electron affinity. So what will happen? The stable electronic configuration atoms like B, E, N, P, Mg, what will happen? They will have a very less value of electron affinity. Why? Because nitrogen, phosphorus, we know they are having half filled shells. So they will be stable and thus they will apply a less force on the incoming electron. Magnesium, what we'll say, magnesium and beryllium, magnesium both are alkaline earth metals. They will attract the electron by more force, the incoming electron by more force, as their outermost configuration is 1s2, 2s2. Okay, and this is for beryllium, and for magnesium is 1s2, 2s2, 2p2. So, and we know that the electrons in s subshell are attracted more forcefully. So as we discussed the trend, so now we can discuss that we can also think that halogens are having the maximum EA in a period. Okay, but we have also discussed about the exception. So considering both the facts, if someone asks you that what's the order of electron affinity in FnCl, it will be this. Okay, O and S, it will be this. Now electron affinity has many wide uses. So now we will study about the importance of electron gain enthalpy. Now what can be its use? So it is having many, it is related to many aspects, like I will discuss, first I will discuss metallic and non-metallic character. Metallic and non-metallic character. Non-metallic character, what does this refer to? Metallic character is nothing but the tendency to lose the electron. And non-metallic character refers to tendency to gain the electron. So what does it mean? If electron affinity is more, the metallic character will be less. For non-metallic character, what we will say, if the electron affinity is less, sorry, what we can say for non, how we can connect electron affinity non-metallic character. Non-metallic character, as I discussed before, is the tendency to accept the electrons. If the electron affinity is more, then the element is having more non-metallic character. If the electron affinity is more, then it is having less metallic character. If the electron affinity is more, then we can say the non-metallic character is good. For example, sodium is electropositive, it's a metal, it's having less electron affinity. On the case of halogen, if we see FCl, they are non-metals, and as well as they are having high electron affinity, they have tendency to accept the electron, they are having non-metallic character. Other uses, other properties which can be derived from electron affinity is reducing and oxidizing properties. Reducing agent and oxidizing agent. Okay. So what does this mean of reducing and oxidizing agents? Reducing agents are those elements which reduce are those agents which reduce the others and oxidizes itself. And oxidizing agents are those agents which oxidizes others and reduces itself. So if we link it with electron affinity, we can say that the oxidizing nature decreases on going top to bottom in a group, while the reducing nature increases on going top to bottom in a group. Why so? Because on going top to bottom, electron affinity decreases. The electron affinity decreases means the tendency to accept the electron decreases, means the tendency to gain the electron increases, and thus the reducing nature increases. For oxidizing nature, we can say, for oxidizing agents, we can say that on going top to bottom, the oxidizing nature decreases, means the tendency to accept the electron decreases, tendency to lose the electron increases. Thus, these all properties are interrelated. Next, what we'll discuss is the stability. Stability of the metal increases on going left to right, because left to right electron affinity increases, while on going top to bottom stability decreases.